Hey, welcome to Quarkus Insights number 126. And we've been going for long enough that we're sort of starting to loop around and revisit some of our earlier guests to get sort of a follow-up on how they're getting on with Quarkus after they've been using it for a while. And I think we're lucky today that we've got KimJohn Quinn to come back and tell us a bit more about what he's doing with Quarkus. So I guess maybe to start off with, KimJohn, do you want to just introduce yourself and explain a little bit about your involvement with Quarkus?
Sure. My name's KimJohn Quinn. I'm a principal and co-founder of Logicdrop. And over the last 3 years, we have fully embraced Quarkus as our primary stack and migrated our existing platform from Spring Boot over to Quarkus.
Cool. And I guess I don't want to. I've got lots of questions, but I don't want to jump the gun too much because I know you've got some slides to show as well. Um, so do you want to shall we start with your slides?
Sure, sure. So I think everybody can see the slides. So basically, what we're going to talk about today, and just as a note, we're super excited, is how we have completely embraced Quarkus and standardized on it as our primary stack. The advantages that we have found from using Quarkus and how it's improved our productivity internally. It's improved our clients and their ability to deliver services reliably. And just all around, after making the jump to Quarkus, we have just found significant improvements across the board, whether it's CI, CD, delivering services quicker, confidence of what's being built, native executables, everything that we have touched in Quarkus has honestly just been a phenomenal experience. So
Right.
that's basically what we hope to cover today with some examples of how we've leveraged Quarkus uh, architecturally that we've found to work very well for us. So, what I'm going to go over is just a little bit of our background because I think it's kind of important to note where we come from and that this wasn't a fast and quick jump. We we started working with Quarkus, or we actually started investigating Quarkus about 3 years ago, and I even found my original questions on the Quarkus dev group. And very quickly, once the questions were answered, we dove into development and ops, where we were taking Quarkus and building prototypes, taking selected services from our existing platform and running through different scenarios. And at the end of 2021, we felt absolutely confident that Quarkus was where we wanted to go, and we decided to completely migrate our 3-year-old Spring Boot platform to the Quarkus platform. So, over the course of 2022, most of us were at home because of COVID and we had a lot of spare time. We almost completely migrated our platform using nothing but Quarkus. So we have no external dependencies. We have nothing outside of Quarkus. We're basically using Quarkus, Quarkus extensions, Mapstruck for mapping, and then just Lombok for syntactic sugar. So now we come into 2023, we've completed our foundation. We've started onboarding new clients onto our platform, and we're migrating our existing clients. And at this point, everything that we've built to date has been so solid that the majority of our work in our platform is really almost all features. We've alleviated all debt from the migration. We've introduced new features, new functionality, and couldn't honestly be in a better place at this point with what we have. And we like to think that almost all of that comes from our switch over to Quarkus.
That is awesome.
How do you feel like you're like when you're dev? How big is the dev team? I guess first off.
Well, that's what's going to be pretty amazing. We're a very small company, 10 people, and our clients are all Fortune 1000 companies. We come from the Joule space. Our original platform, we, long before Kajito, long before Quarkus, we took Joules, brought it into Kubernetes and native, and built an entire platform that empowered users to be able to control and test and design their own rules and deploy them at will, much faster than they could with conventional development cycles. So for the last 10 years, we have been mostly in working with Joules. We focus on nothing but business automation solutions for our clients. And in some cases, those clients, the solutions we've provided are mission critical. If our rule solutions fail, people get sick or can have reactions to allergens or ingredients in products. And all of our solutions are applied at a national or a global level. And we have banks, we have global law firms, automotive vehicle simulations, uh, all kinds of stuff. So, we're not new to enterprise development, and we have some pretty heavy background in it. And one thing that all of our clients have seen from introducing business automation with Joules is they have all seen significant improvements. In some cases, hundreds upon hundreds of hours have been reduced from their processes by using Joules.
And how did they like? What was the learning curve like when moving from Spring to Quarkus? Because if they were all familiar with Spring.
Oh, well, so that's actually my very next slide. Why we chose Quarkus.
I swear I haven't seen your slides. I didn't know what was coming.
Not a problem. So internally, if I start out with our own development team, internally, as our application grew using Spring, it started to get much more difficult to maintain and enhance. And what was happening was we were wrestling a lot with Spring's mechanisms, how Spring handled injection, just what we call Springisms. And when we went to Quarkus, what happened was it was basically a better way of doing Java. It was based on Java standards. It was very familiar. We were able to quickly bring up our own developers in Quarkus and almost immediately have productivity and see gains in speed to development, speed to deployment, because we weren't wrestling with black magic that was sitting under the hood. Everything in Quarkus, it either worked or it didn't. And if it did work, it was based on, again, standards, JAX RS instead of using Spring REST. Injection was very straightforward. Everything that we injected would work. We didn't have to wrestle with Spring Boots and auto configuration and, oh, I got to load this before I need to load that. And then even coming down to configuration properties, there was just so much stability in moving to Quarkus that we found our own internal development increasing at a rapid pace. And if you recall from maybe the last presentation that we gave, we were seeing a difference where a Spring Boot feature for us could take 1 to 2 weeks. At this point now, with using Quarkus, we're measuring things mostly in days. We're able to get a new feature into play in as quick as a day, and if we don't like it, we can pull it out just the stability and the reliability of using Quarkus has been amazing.
So cool.
Now,
Yeah, it's sort
oh,
of
go
a
ahead.
bit silly. Oh, no, I'm just thinking, like, a lot of people, maybe, or one of the questions that I sometimes get is, Quarkus is new, is it stable? And, some of your experience is that, yeah, it's really stable.
Oh, it's been amazingly stable, and we do everything as native executables. So everything that we deploy ends up being a native executable, and we have not had a lot of problems with that. In fact, honestly, we joke about this internally because we've been trying to work and flesh out our native test cases. I would say a majority of the issues that we have when we build native executables tends to be register for reflection. Something just gets missed, and it's obvious though when we see the error, and that tends to be the bulk of what we've hit with the native executables. Uh, we run Renovate. We update our builds across all of our projects either the same day or the next day that you've cut a release. We don't even look at it anymore. Now, granted, that's running through all the test cases when it updates the dependency. But when you've cut a new release, we've updated as soon as that release has come out and had very few problems. Interacting with Kubernetes, everything has worked extremely well on that side. We've had a couple of security issues that we've dealt with, or new versions of Kubernetes that have changed the way they handle some of the manifests. But for the most part, we really haven't wrestled with changes there. And then the configuration, we find that we can adapt to the configuration very well, either native or JVM deployments, and everything works. I mean, that's really what it comes down to. For us being such a small team and playing in such a big pond, we need to be able to build out features while supporting an existing code base as quickly as possible and have the confidence that what's there today is going to work tomorrow. And that's what we see with Quarkus in every single aspect of our platform and what we evangelize to our clients as well. Now, of course, the very last point on this deck is actually really important. The documentation has been, for us, great. Everything we need is always in one place. It's easy to find. It's always to the right version, which we've had with other stacks. And the support from the team has been great. Questions are answered within 1 or 2 days at most. So we felt confident embracing Quarkus fully and making that jump. And for us, this was over a 3-year time span. It wasn't a quick jump. We didn't just pick Quarkus and say we're going to go with it. We ran a lot of scenarios, did a lot of testing, a lot of vetting out. We looked at things that we had issues before, and we tried to simulate them using Quarkus. And by the time we made the jump, we were confident that Quarkus was the right choice. Excuse me. So now we get into the challenges that we face. And even though we build a platform that streamlines our clients' usage of rules, we also are looked at a lot for thought leadership in other projects within these clients. And ever since we made the jump to Quarkus, we've begun evangelizing Quarkus as a better Java to our clients. And what we've seen is that Quarkus doesn't necessarily have a huge learning curve. If you know Java, you're going to be pretty comfortable in Quarkus, and you're going to find it pretty easy to work with. And, like the site says, you're going to have a lot more fun. Just dev services, a lot less wrestling with complexities that you don't necessarily need to deal with. So basically, we've been not selling, but touting Quarkus to our clients as a way for them to build their own services better. And rules add to that complexity. And that's something that a lot of users look at and they say, it looks really complicated, but it is what I want to do. We've also found in our experience that business users are rarely really involved in the process. They may look at the rules or they may look at the decision tables, but in every case for us, there's always been technical resources that are actually doing the work. And then outside of Quarkus, deploying into a cloud native infrastructure, our clients generally are not prepared for that. They don't have the resources available. So they find it a little bit overwhelming what to do after development. And even though they may build a service really quickly, what to do, how do they bring that into their cluster? How do they maintain it? How do they update it? These are all pieces that we wrestle with when convincing our clients that they should go to Quarkus. And then on top of that, with the infrastructure, there's a lot involved in deploying something effectively into that cluster. You have logging, you have telemetry, you have monitoring, even how do you roll back? Our clients either have existing processes or they don't have existing processes. And in some cases, they want to fit the Quarkus build into those processes, yet they're not fully prepared. So overall, what we see when we try to evangelize Quarkus to our clients is that, yep, we can prove to them that Quarkus is the way to go. They see the benefits of Quarkus. They understand why it could help their organization, whether it's cost of resources or efficiencies. But as you pointed out earlier, there's that whole uncertainty because they think it's new.
Yeah.
But if you're talking about like deployment challenges and whatnot, they'd have that regardless, right, of technology choice?
Not necessarily, because one, they have to introduce, if they're going to go down the native path, they have to introduce the native builds. They have to have a way to test the native builds. And then even outside of just the deployment, they have everything else that surrounds that, the monitoring, the logging, the configuration that gets it to play in their cluster. So they can bring it in, but to bring it in, what they have to do is bring in additional resources to either set that up from the ops side or manage it, because in all of our scenarios, it's a new process.
How much Quarkus is exposed to your end users, just sort of out of the box for your product?
Oh, well, this is where we make a pivot, because where we originally came in with focusing primarily on how do we simplify rules and building rules and decision tables for our clients, what we realized when we were talking to them is, what if we could wrap up the whole process around building services using Quarkus so that the learning curve is reduced. They can focus purely on building a service using Quarkus or building rules using Kajito. And what if we can take all the other surrounding pieces and wrap that up for them so that they don't have to worry about it? And that's where we come in with our platform. We simplify the end-to-end process so that users, business or technical, can focus purely on what they need to do, and all of the other components are handled from our end.
Cool.
So what I'm going to go through now is I'm actually going to, I'm sorry, my voice is going here. I'm going to actually walk through examples, one, of what we do with our platform to streamline adopting Quarkus, and two, just the various patterns that we have found to work very well for us when we're using Quarkus. Let's see if I can do this with 2 windows here.
Hooray.
Oh, but I lost my notes.
Oh no.
Let me see if I can find my notes. It was so close. Here, if I move this to my other window, I can do this. All right. So this is our, oh, go ahead. I'm sorry.
Instead, there was a question that just came in. Could you elaborate more on the bootstrapping of multiple services for easier development and testing?
I'm going to show you. That's actually been very handy for us too. And I'll explain it in some detail. So this is our platform right now that we've been bringing clients on. And again, our goal is to get users, whether they're using our platform or not, using Quarkus, being able to deploy it and being able to manage that. So what we do is we wrap that whole deployment process up inside of our own system. And these are leveraging all Quarkus extensions for what they would generally interact with. And they may bring this into their own CI process, or they may use it as is. Then what we actually do is we build out customized workspaces depending on what you need to do. If I want to work in Kajito, they can create their own workspace that has been set up already for Kajito with the Quarkus toolset. They can stay within their existing processes. So if they're using Git, which is the preferred approach, they can pull code from that repository. Then when they're done, they can publish it. And when they go to publish a service, they can pick if they're going to run in JVM mode, if they're going to run as a native executable. They can create domains. So you can think of domains as a staging or production or whatever you want. You can add scale. So if I know I'm going to have a certain scale out of the box, I can establish that. And this will go out and actually build the Quarkus service, and it'll augment what they've done from a configuration perspective using Quarkus to build and deploy that executable that immediately becomes accessible. So if it
kind of looks almost like you've built your own kind of like backstagey type thing.
Exactly. So it handles, and actually this is kind of neat to point out, one of our baselines is everything needed to be able to run out of the box using your own examples, because we wanted to demonstrate to the clients that we're not really changing Quarkus or, adding a bunch of controls on top of it. All you need to do is focus on what the services that you need to write, and we'll handle publishing, we'll handle the tooling, and we'll handle the versioning for you automatically. Ooh, screen's so big, I'm not used to it. So what this allows us to do is really cover everything that somebody needs to get started with Quarkus. And in a lot of cases, we're working with very specialized teams who want to build Quarkus services, but again, they're afraid of making that jump or making that investment. So from a user's perspective, again, we set up let me open up a terminal here. Oops.
And can we go a tiny bit bigger on that terminal font?
Where is the size? Can I
You
just
should have this.
You could do like Control Plus, I think. You're on a Windows box. That might work.
There we go.
Hooray.
Okay.
Thank you, Eric.
Yeah, I have to remap my Mac keys to my Windows keys here. It's been a long time since I've done Windows.
Oh, no, you know what's cool? Actually, so I do a lot in I use WSL on the Windows box to get to everything. So this is actually using your own hello world that's over here. And what's nice about the way that we've set it up is, of course, I can run Quarkus Dev in that workspace out of the box. Oh my God. Oh.
Holly and I have this conversation all the time, which is called audience-driven development. Like it all works great until someone else is watching you do something.
It is. Hold on. There we go. So what I'm going to show is that I can debug this while I'm online with the code. So for our developers that use this system, they're able to write code and they can actually sit with their clients or other developers and they can debug it while they're working in it.
Yeah, we've moved on from audience-driven testing to audience-driven debugging, which is pretty cool.
So if I go there and then I say here, I want to debug the service. And I think I got a breakpoint there. Okay. So now I can hit my breakpoint live while I'm working in the service. So again, we're not really changing what people do or how people do it. What we're doing is letting them focus on the service itself. So now I've made my change. I can go back to here and I can click publish and I can publish that as either a JVM or a native executable, and it becomes exposed to my users. Now, the other thing that we've run into is when you want to run multiple versions of a service. So we have clients that might have a V1 and a V2. They want to run them in parallel and eventually close down the V1 after people stop using it. Our system will let you create various versions of that same service and deploy them live. So again, they don't have to worry about the ops process themselves. They can build the service, make the changes, fit within their existing processes, and deploy as many of them as they want. They can even deploy them to what would be considered different domains or different namespaces that may be out there. So controlling that whole process is really what we've started to do now with our platform.
That's really nice. I saw a talk from Adrian Crocroft recently, and one of the things he was saying was that one of the things that got forgotten in microservices from when he started talking about it was the whole versioning thing and the idea that you would deploy multiple versions and that you would have some sort of intelligence about how you deploy multiple versions and how you route traffic to them. And that's what sort of keeps the whole system able to move forward without having to be completely coupled together.
Exactly. And then even from a developer perspective, being able to work with those services as you start to grow the number of microservices, and that's where we'll get into that Bootstrap. We found a good way that we can use locally for development, but also one of the benefits of Quarkus, because of the native executable, it's opened up this whole new world for us on the cluster side. Our developers can deploy the whole cluster as native executables into their own namespace as if it was deployed in staging, or we can kind of switch the way they communicate using something like Stork. And because the native executables are so small, what we can do today with our whole team, we could never do before with our other platform, because we would just drain the cluster. So it's not uncommon for us to have hundreds of pods running for each branch, each developer branch. We build a preview and it gets deployed out into the cluster, and it's fully configured for that namespace.
So nobody, not one developer is not stomping over another developer, and everybody kind of can do things in isolation.
Exactly.
I saw I got sort of forwarded an email a while ago, and it was going into one of the Red Hat consulting teams, and they were sort of talking about something else. But the starting point for the conversation was it was a startup, and it was the CTO of the startup, and they had, I don't know how many services, a lot. And even though he was the CTO and he'd been given this super shiny new laptop, he couldn't actually start all of the services up because they just consumed so many resources. And then, of course, we kind of went back and went, have you tried Quarkus?
We meet a lot. So, and it's funny because we have a lot of clients who have pretty big technical teams. And when they go down the microservices path, they take the very purest approach. Every single method is an individual service. And then they wonder why they can't spin up the 400 CRUD methods even to communicate with each other. Or they're running Docker Compose, or they're running different environment. It's all over the board on the microservices part. And another reason that we went to Quarkus was we were finding it increasingly difficult in our existing platform, just like you said, to run and develop all of those services. We had it working, but it was difficult, and it took a lot of time. It took a lot of resources, and there was a lot of corner cutting. Well, I can't run all 50 of them, but I can run 15 here, so I just won't test that part. And for us now using Quarkus, that's almost went away. We can run the whole environment in Minikube, in Kubernetes, or through our bootstraps. We can pretty much accomplish everything the exact same way. So this is an example of different versions that have been published that can be managed, they can be recycled, they can be stopped. So it's not uncommon for us to have at least 2 versions of APIs, or even for experimentation. We found we have clients, they want to do experiments. They don't want to really deploy it publicly, but they want to test something. This lets them do that in isolation with the same code base. So going through that, we even have Quarkus building .NET containers and using it to integrate other services that sit outside of the Quarkus space, or Cogito. We also have the ability to run through and test.
So does that fire a live request into the system?
Yep. As I said, the beauty of this is the minute I click publish, I'm deployed. I've got a fully running service. I have telemetry, logging, metrics, everything that you would normally have to go through and configure, all set up automatically. And we do a lot with Quarkus, the Quarkus configuration extension and the Helm extension. So we augment the configuration prior to the build so that we can set the build time properties. And then we use the Helm extension to basically configure runtime properties or cluster related properties. And what we found from the combination of those two is we can completely adapt these builds, when I say on the fly, prior to you building that executable, for a variety of different scenarios, and deploy it out there. Any questions?
Not for me.
Nope. No, this is cool.
So all of this is being managed through Quarkus, and it's being used to actually build Quarkus. And the most recent one that we just started to add is Dash. And what we've focused on initially is building the platform and the foundation. Now, coming from our past experience with our existing platform, we already know that we can augment all of these systems and provide the data integration that ties them together into one seamless experience. So going from rule output automatically into Dash and providing that as dynamic data, our next phase, we're going to start tying these together more with our APIs so that the data flows from your service into all of the components.
And if folks want to know more about Dash Builder, we actually had a Quarkus Insights on Dash Builder a couple of months ago, so that's available as well for people to look up.
So what I'll jump into now, and make sure I got my little note page over here, is kind of what we've found to be, the patterns that have worked. So I'm actually using our platform to demonstrate code from our side that was used to write this platform.
You make the font a little bigger?
Yeah, let me get my slides here. There we go. Okay. So one of the tactics that we've found to work really well is instead of taking that purest microservice approach, we found that grouping the services together just has overall made life a lot easier to work with. So we don't build them so granular that we've got hundreds of services floating around. We try to group them into reasonable domains of what that functionality is. And we also use that as a way to decide what extensions we're adding where. So for example, if I'm using the AWS S3 extension, I really don't want that kind of spread across all of the services. One, I don't want the overhead of building the native executable with it. So what we do is we focus those into specific services themselves, and then we leverage the REST client to communicate. So if I look at the client service, it does everything that's related to client, and that's it. If I need to do anything related to client in another service, that service is going to communicate with it through its RESTful interface. So what that means is that as we build services, we tend to build them very dry. We don't really reuse services within other services aside from communicating between each of them. We keep them very isolated, and that's really helped us build out the platform with less risk of having something that's intertwined and going to explode when we make changes. So it gives us the ability to refactor a lot better, and just really manage where the functionality is originating from. Now, the other one that we found with Quarkus to be extremely helpful is really working with the configurations. One of the things that we've liked about Quarkus is the fact that you really have curated that configuration for as far as we can tell. When I need to access a Mongo connection string, it's generally just in Mongo. So I don't have to have 5 different Mongo properties scattered about. And so using the configuration and leveraging it within our specific components has allowed us to build these building blocks and plug them together and immediately have the right configurations for that build. So if I were to use this Mongo component, it's going to bring along what the Mongo configuration is. I can always override it if I need to, but for the most part, this plays not only within our CI process, but also as a part of the augmentation that we do during the build. We know where the properties are coming from, and we know exactly what they're going to do when we apply them.
Are you doing, because I see you're using profiles there, are you doing any kind of like profile inheritance? Because that was added
Yes.
into the config a little while ago.
Yes, we are. Our cluster profile and our Kubernetes profile uses the cluster profile. And so we know we always target Kubernetes for the most part. So what this is this is our bare minimum configuration for the Kubernetes build. And then we have a cluster one, which really what that's doing is it's turning on all of the other components that we would generally use in any cluster deployment, whether it's native, whether it's Minikube. So telemetry, config maps, all of that stuff. That's what exists in our cluster parent. And then Kubernetes or native become very specific to that deployment. So I think down towards the bottom, we have a Minikube one. And this has worked extremely well for us as far as building out the Kubernetes deployments. Now, we use the Helm extension pretty extensively because there's a few properties that we want to control depending on how and where it's being deployed within the cluster. But even then, it's not a lot of configuration.
And so one thing that kind of just jumped out at me, like all the stuff that you're showing, you're using cloud-based IDEs. Do you do like what you would actually call local development, like on your own laptop, or is it all kind of remote, local in the cloud kind of thing?
Oh, no. No, we do both. Most of us will develop locally, and then for our clients, they're either working locally or they're working out of our platform editors. But we like to think of the platform editors more as small and quick and collaborative tools, not necessarily your day-to-day development. And that's one of the reasons that we wanted to fit into existing processes, because it's using Git. Whether I'm working with it here or I'm working with it locally, I'm still pulling it from Git, I'm still pushing it. And even if I'm outside of our platform, you can still use publishing, testing, Swagger UI. That's all still a part of the build. It's just that it's done outside of your local development. So the other tactic that we've found to work very well for us is we wire all of our services pretty much at the resource level. And the reason that we do this is because we know, for example, we're potentially going to be swapping out some of these clients with other components. It might be GraphQL, it might be gRPC. It's not always going to be the REST client. By wiring up at the resource level, we can have versions of this resource that could be completely different. And it allows us to build much smaller, much more focused components that we can test and then tie them together here and have variations without having to muck up with the services, anything that's outside of it. So for the most part, our services are very standalone and they get tied together at the resources so that we can make changes and we can basically pull together all the different building blocks here. And then when we go to test it, get a pretty decent coverage rate at that point.
Do you do any contract testing to manage the relationship between the services?
Yes, we do. We have a pretty extensive set of tests that we run through. So we generally start out with building mocks for the services and then building mocks up to the resource. And then we have a separate test that runs for the integration, which gets applied to the native or the JVM builds themselves. So when we look at and we have a lot of abstractions that we've built out around the testing. And what we've found is that our tests tend to take more of a BDD style to our test. So they're not as much what you would consider unit tests, but oftentimes represents stories or flows that need to happen across multiple services. Any questions on that?
Have you looked at something like Pact or whatnot for like managing or testing like the interactions between services?
Yeah, we've looked at it, but what we actually have an integration test suite that we've built out that runs through those interactions between the different services.
Got it.
So the other one, and again, using the REST client, we use the REST client for all of our internal communication. So we have system level services that we want to communicate with. And in those cases, we're oftentimes working with coarse-grained objects. So the full object itself, where when we're generally working at a resource level, we have requests and responses that we've created that give us control over what's going out and what's coming in. Now, we've learned from experience from our previous platform about immutability, especially in a reactive flow. And what we do is we use Mapstruct as a way to achieve that immutability in sense super factories of the objects, but it also gets rid of all of the boilerplate. And so even though we're creating POJOs that we're mapping back and forth, it gives us good control over those objects, and it lets us use the Hibernate validator behind the scenes and apply that validation a lot more effectively against the whole object, knowing everything's going to be there. It also allows us to be a lot more stateless in what we do, because when I'm passing something between services, I'm passing it as a whole. So it minimizes the need to go out and do additional lookups for data when everything's right there. Now, the last one, because our services are not reused, we don't extend services between each other, they're all standalone. With every one of our domains, we build a bootstrap. And what that bootstrap does is it actually aggregates those services, allows us to spin just this bootstrap up and then do development against the bootstrap, which has all of what would be the external services as well as what we're working on. And this has worked really well instead of using something like Docker Compose to spin things up, because all of the services that we're remotely interacting with are right here. So we get the benefits of running Quarkus Dev, where we can actually work on our code and we can interact with the services the same way.
So is it like a big mock essentially of all the underlying services?
Well, that's the nice thing. Because of the configuration, when I drop in this client service, it's pointing to my local database or whatever data store. It's acting exactly like it would when we deploy it into the cluster. The biggest difference is all the URLs and the ports are lined up for this bootstrap.
And do you use any dev services then when you're using the bootstrap?
No, we do not. And the reason that we don't use dev services right now is because we have other services that generally talk to those same containers. So
Yeah.
we've actually built up on our side. Of course, I wouldn't be in an example that has one. We've actually built up on our side a bunch of tasks to spin up Mongo, spin up Redis, spin up Postgres. Because again, we have other things that talk to those same data stores that are outside of Quarkus. So we haven't used dev services because it pretty much keeps us only within Quarkus, which would work fine. But when we need to access it from another service that's not Quarkus related, we still have to spin it up. So in trying to standardize our environment, we have a support project where somebody can spin up all of those containers as they need. Keycloak, and even though you do have dev services for everything, again, it's more that we have things that sit outside of them that I may not even be in VS Code or Quarkus. I just need to access the Keycloak admin panel.
Yeah.
And so, oh, go ahead.
I was gonna say, speaking of, just to go back to the MapsTruck thing, I'm a big fan of MapsTruck as well. I don't know if if you're moving any of your services to Quarkus 3, they were missing the Jakarta CDI injection. That's been released actually as of this week. So in MapsTruck 1.5.4, you can have Jakarta CDI.
Yeah, I didn't know if that was recent or not, because when we did the upgrade to 3, I think actually they just came out with a release for some bug fixes on MapsTruck. They had this Jakarta setting in there.
Mm-hmm.
No, we really are pretty fond of MapsTruck, and we use it, just being able to validate our objects quickly. We also started to tie in, have you heard of Instantia? So one of the things we found, like I said, when we were deploying native applications, is that we would miss a property. Something wouldn't get included when the native build was created. So with Instantia, we can just very quickly apply mock data to the whole model at any depth and verify that that data comes back and forth from the native services.
Interesting.
So it's been really helpful to validate that the payloads are there. We're not necessarily looking it's the right data. We're looking, did I get a client ID back? Did I get this? Did I get that? And Instantia just lets us basically populate that object automatically. So this is something we spend a lot of time building our testing harness to try to ease the testing across our system. And one of the most important ones, of course, was wire mock. Since we do a lot of mocking, another way that we can actually work through the system is we can just apply the wire mock service, have it supply all of the payloads we would typically expect from the REST client, and then just work on our service. But more importantly, when we go to the native builds, we use wire mock behind the scenes instead of having to spin up all of the services in our CI system. So wire mock supplies what we need at the CI level, and then we can run the native test against that service and really just validate that it's doing what we need to. And we're really just trying to reduce the resources and the load on the CI system at that point.
How long do your builds usually take?
We can go from a completely fresh AWS instance, and we do everything in CI/CD. We can go from a fresh AWS instance to a fully deployed cluster with all of our services in about 45 minutes. So excluding the native build itself, and we've been playing with different sizing. Generally that runs 5 to 10 minutes per service, but we run them all in parallel. So of course it's just 10 minutes, and then everything else is automated.
Yeah.
Now,
and how many builds it?
Pardon me?
How many builds a day how many builds a day do you think you run?
75 to 100 sometimes. All day long.
Yeah. Some real computers working hard.
It's interesting. So we use GitLab primarily as our CI/CD system, and we've really tooled that out. Everything that we run through the CI/CD system is completely automated, right down to if you push a merge request, it automatically goes into your own namespace in the cluster, and it's all configured. So we run a lot of builds, and what we're finding right now, and we're looking into this, is the number of test cases seem to be increasing our build time. So we're trying to figure out if it's something on our end, or if it, are we doing something wrong. But we definitely have seen that over the last year, especially as we've added tons of test cases, the build times have increased in those. So we've tried to split them apart with unit tests and different levels of integration testing. But for the most part, our builds run, 10 minutes for a single service and you're done.
Yeah.
Is there any other
I
questions?
think we got about 3 minutes left. So is there anything else you want to show or talk about?
No, I mean, overall, like I said, the experience with Quarkus has just been amazing. The various extensions, the configuration, Helm, Stork is another one that we use quite a bit. Everything has always continued to just work. We very rarely are wrestling with issues that revolve around configuration or even bugs. And a lot of times we can find what we're looking for in the documentation pretty quickly. And so it's allowed us to really focus on building features. And what we're finding now as we onboard more clients and migrate our existing clients, they're starting to see benefits within their own organizations, being able to build services quickly. And from a cluster side, the savings on resources, the utilization, no one has to date said Quarkus has not been an advantage. It's really been convincing them to make that jump.
Yeah, it's that inertia, isn't it? Yeah, thank you so much for sharing all this. This is really interesting. It's really nice to see that the same good experience that you had a couple of years ago when you first tried it has continued. So I guess last call for questions in the chat.
I don't see anything.
Don't see anything. No, so I think we can wrap up. And yeah, thanks so much, KimJohn, for coming back and giving us the update. Yeah.
We definitely enjoyed it. We'll keep everyone up to date as we move along in Quarkus.
Yeah, we can get you back for Quarkus 4.
We'll try it.
See you all.
Thanks. Have a good one. Bye.